Is now recording. And yeah, just to introduce Maciek, he is 20 years experience or has 20 years experience in AI. He's a PhD in AI before it was a popular thing to do, with a PhD in over 20 years ago as well. And his experiences across a lot of business problems and a lot of industries and the application of AI. So with that, I'll pass over to Maciek, and he'll take you through the demo style webinar today. Thank you.
Thanks, Sam. Thanks for the nice introduction. I'll try to run it as fast as possible. No one wants to sit through lengthy webinars, so let me just get right to it. First, Sam, can you see my screen yet?
Yes.
Am I sharing? Okay, cool.
Yeah.
So there will be a few minutes of PowerPoint. Then I will quickly move to how fast and easy it is to build the models, the AI-driven models these days. Then there will be a twist. And there will be final project or two delivered, and we focus on business benefits throughout the presentation as well. So let's get on it. If you don't know what Xpanse is, we built Xpanse around the major problem when it comes to customer analytics, which is finding correlations between your data and your business problems. And what Xpanse is doing, it's interrogating the data and finding the correlations with your business problems autonomously and on autopilot at a massive, massive scale. And we'll show you a glimpse of that on a small scale during the demo because we want to keep it fast. What it means for you, it's super fast time to insight. It's much lower cost of analytics than before, and it's much better value extracted from your data. So a quick intro to correlations, because you will be seeing those charts in a few minutes. This is a made-up example. You can see the correlations are about overlaying two pieces of information. So in this case, it's a distribution of the population of students. You can see that most of the students are around 20, 25 years old. And then we overlay a KPI. And in this case, in this made-up case, it's an income. So you can see how for the younger students, the income is very low, and then it goes up with the age. And this is what we called correlation. Like if this yellow line was flat, then there would be no correlation. If it was going down, there also would be correlation. So what we are looking is for these differences between the distribution and the KPI values. Another example, say the same population of students and a car accident ratio. So you can see young people usually having more accidents than more experienced drivers. And then unfortunately, the car accident ratio can go up. So that's how you read those charts. In Xpanse, you will see it as an example like that. So this is pulled from a case study that I'll be showing in a moment. The dashed line is the average conversion rate for whatever product you are trying to sell. And the solid line is the actual observed conversion rate. So it's fairly easy to see that people who live in towns, there's 1,000 of them in our data set. 35% of them converted successfully, while from the larger population of 2,600 people living in rural areas, only roughly 24% converted. So in a sense, this is a micro model. Like if you were forced to use just this information to form your marketing campaign, you would go after people living in towns and you would avoid people living in rural areas. Now, the power of machine learning is it searches for many, many correlations and combines them together into propensity score, as we call it. And you may be seeing these charts as I go through the analytics process in different shapes or forms, but it's all the same kind of information. It's an underlying distribution, and we are observing how the solid yellow line behaves. Are there any differences? Once you can read one chart, you can read all of them. And what we are looking is exactly that. We are looking for dips and contrasting with heights. If it's flat, that's bad news. It means whatever feature we are analyzing, it's not correlated. So now moving to the case study. What we have here is a bank that wants to call their current account holders and offer savings accounts. And they don't want to call everybody. They want to select the best prospects, and they want to avoid calling the not interested ones. Xpanse or not, whatever way you deliver this kind of a project, you need to start with historical data that will contain some sort of a training information, training labels or target or objectives, as we call it. And they usually come from two different sources. It may be a historical campaign, like similar that we want to execute in the future, or we may observe and extract the organic product take-up from the database. There are like two main ways to find the target. In this case, we were lucky to have historical campaign results, and let us describe how this works. So when you train the model, there was a population of customers targeted with savings accounts offer. And as an example, Sarah had a current account and she did sign up to savings accounts in the previous campaign, while John also had current account only, but he did not sign up. So the way it works, we use that information and all the other input data sources that we'll walk through in a moment. And when the model is deployed and is scoring new leads, it's scoring for equally best and bad leads. So this is an example. Tom and Becky only have current accounts, and it turns out Tom is quite similar to Sarah. And this is the profile we want to find. This is the kind of customer we want to target. Now, Becky turns out to be similar to John. The way we know it is she will receive very low score by the model, and we will try to stay away from this kind of a customers, at least with the savings offer. What does it mean that Tom is similar to Sarah? It can be anything that can be extracted from your data and correlated with this sale, no sale target. Stage in life, earnings, spending patterns, whatever data we can pull up from loyalty programs, and whatever signals we can extract from the data that you have on your data warehouse. Now, this kind of target definition, as we call it, takes a shape of a table. These are the call outputs from the previous campaign, and you can see there's an account ID and there's sale. So that's our Sarah. There's another account that's again a profile similar to Sarah, and no sale. These are our Johns. So these are the labels information that will direct machine learning to train the model. And this is when in a moment we'll move to the demo. Now, before I do that, I want to jump over all the technicalities and describe what are you looking in the data as a marketeer. And you can look at many things, many metrics, but I want to focus on two of them. So one is uplift or cumulative lift. It's pretty much the same. And we'll be looking at these charts in a moment. And it tells you how much better is your performance, your campaign performance, when you use the model, when you use the scores. And in this case, it's telling us that if you limit your targeting into top 10% of your customer base, you will get 59% better performance compared to random calls. It's better than nothing, but it's not great, and we'll walk through that in a moment. But that's how you read this information. It's important to know how the model can contribute to the performance of your campaign. Now, the other metrics you may not be as familiar with because there's very few tools that actually provide to do that, is the monetary net benefit of the future campaign that you're planning to run. And what you see here is, say, our broad customer base split into 100 microsegments. We call them percentiles, and they are sorted by their propensity to sign up to a product. In this case, it's a savings account. And you can see on the left, there are customers, like every block, every bar contains roughly, in this case, 130 customers. So on the left, we have customers with very low propensity to convert, and on the right, there are high propensities. And you will see that later on in practice. In this case, the top 5 percentiles are selected for campaign. And the tool is telling us that overall, the net benefit after all the cost we encounter, if we target these top 5% of our customer base, the net benefit will be 27,000 euro or dollars, or whatever currency you are using. So now let's dive into how we get there. Quickly, this is our link to data warehouse. We have our target. That's what you saw in the PowerPoint. So this is sale, no sale information from the historical campaign. We have tons of data. We have monthly summaries, loyalty cards, customer demographics, credit, and some payments to utilities. So that's the typical structure of the data warehouse. You have multiple tables with thousands or millions of records about your customers. I'm just going to make a copy of that. And just to make a very quick run, I have some data that I want to exclude just for the first run, like account transactions, just to make the first run really, really quick and to move on. So I'm just using subset of the tables. That's my target information. I'm going to quickly mark that no sale is people we don't like and sales are people we do like. And this is the moment where we ask Xpanse to interrogate all these tables that were marked as inputs and extract possible correlations that will shed a light on what correlates with the successful sales and no sales. And this should take only a few more seconds and we will be done. So, yep. Now, all these multiple tables here that were marked as inputs were compressed into modeling dataset, which is required by machine learning. So we have it done automatically. And now we can look at the performance of the model. So the overall, I should introduce the measure of Gini, as we call it. It's a overall predictive power of the model, and it spans between 0, which means the model is completely random, through like 0.5, which means it's halfway accurate, to full 1, which means it's a crystal ball, like every prediction is accurate. And what it means is if you follow the model, every call would be a sale. And obviously, in real life, it never reaches this level of accuracy. But this, you can see, if it's between 0 and 1, this is quite low. But let's look at the uplift. So this number in yellow, 1.42, that's the important one. It tells us that we can get 42% improvement compared to random calls. So in real numbers, say, if by random calling you would get 100 sales, then if you followed the model for the top 10% of your customer base, you would make 142 sales. So it is sort of improvement, but it's really not what we see in cross-sell and upsell campaigns. We would expect something much better. So I'm quickly going to just make a copy of this analytical iteration, and I will add those tables that I excluded before just to see there's bank web data, account transactions. So that's the detailed transaction after transaction on every account. So mobile top-ups and utilities prepaid log. So we are just adding more data. The target is not changing, and we'll just run it again and seeing if this will get us a better model.
Just a quick question while this is running, Maciek.
Yep.
With regards to the Gini, what is a good threshold for it?
Almost every meeting, this question. There is no industry standard for the Gini because it depends on the problems. Like in banking, in risk modeling, they have some sort of a standards. In marketing, you may say any improvement over random targeting is good. So there is no standard because it depends depends on your data that you have and depends on the complexity of the problem you're trying to solve. However, if the Gini is below 0.2, it definitely calls for a debate if the model is worth using. If the Gini is above 0.8, it calls for a debate if we are discovering some fake correlations because it's almost too good to be true. And if it's above 0.9, it's definitely a red flag because it means it's just not seen. If we are solving hard problems, it's never that high. Now we have second execution. So the Gini is bumped up now, 0.17, as I mentioned, slightly above 0.2. Not quite happy with that. The uplift on the top percentile is now higher. So instead of, what was it, 42%, now we have 62% better than random. Again, our experience, this is not good enough. So it's a real case study that we work with. So what we did, we stopped building models and we started investigating what's going on with the data. And let me flick to the PowerPoint. How are we with time? Okay, I need to hurry up. So the model is quite poor, and this is where the twist comes in. As we analyze the detailed data, where the sales, no sales flag came from, it turns out that it was actually quite a mess. It turns out that the successful sale was not only Sarah who was saving, but also George, who needs a credit card. And the no sale were all sorts of other targets as well. We'll see them in a moment. So if you think about it, the profile of a person who wants to save is opposite to the profile of a person who needs a credit card. And that prompted us to extract more detailed answers from the call center to see what exactly was going on. And that's this is the table. So you can see this is the detailed code outcome. Sale could be savings sign up, but also sale could be linked to credit card sent or credit card sign up actually on the call. So what we did with that is we used this much more detailed target to build a new model to direct machine learning to the profiles that we want to analyze. So you can see these are the answers given, like the most frequent answer is no answer. So no one picked up the phone. There is some under 18, there is some wrong person hung up. Oh, here are our savings. So that's the target we want to build the profiles on for the future campaign. And the others will, I'm just using my mouse to flag. So refused savings, we don't want to target them. Credit card sign up, we don't want to target them. I'm just going to leave the other two. So the process now of building analytics is about choosing which kind of answers are good profiles for you, meeting business objective, and which profiles you want to use as not a good one. I'm just going to kick that off. This should take about a minute. I didn't show the correlation charts.
Another question there, Maciek. We can see on the screen number of features tested and number of features in the modeling data set. What is the difference between those?
Okay, so in real life projects, every feature is like hypothesis to test, a kind of aggregate. It could be like a region where you live, or how long did you live in that region, or what's your average balance before signing up to the credit card. So Xpanse is creating in real life projects up to, I mean, there's no limit. Thousands, tens of thousands, sometimes even hundreds of thousands of features tested. And then there's a whole set of feature selection algorithm that brings that number down to under, say, 1,000, because a lot of features come out quite redundant, very repetitive. A lot of them also come out with near zero information value. So that's why the difference. No one really wants to analyze 10,000 charts. So we keep that final analytical data set much leaner.
Okay, just two more small questions. one is back to the Gini. Could you evaluate a different Gini for different subsets of data? So could you find a Gini number for people less than 30 and older than 30? Maybe seeing that the Gini can be better for different age groups, possibly due to more data being available for people greater than 30.
This is excellent question. So in this case, from this very short question, what I see is two distinct segments of the customer base created based on experience of the person who's running the analysis. If you see two or three or four or more separate segments, it calls for building separate models or separate analytics for those different segments rather than keep them together. So then you would have separate Gini for those different segments. And it's all about, you can use the same input data. You just need to have, say, target and say, well, that's my target for what was the question, like over 30s, right?
Yeah, yeah.
So one target for over 30s, other target for under 30s, and then run separate analytics, and you would see different genes for them.
Okay. Just one more quick question regards the like the ML is determining what features are getting tested in the modeling data set. But in real life, sometimes the business decides that they want a specific feature, even if there's no strong correlation in the data, just as a business rule. Is that, how does Xpanse deal with that?
It's very simple because we do that on our projects as well. If you have already some sort of a code that builds your favorite features, then you just attach them to the target table. In this case, this target table has no features, but if you attach 440, 400 of your own features to this table, then they will be taken into account by machine learning and they will be pushed to it. So you can do that. We just need to construct this table differently. Now,
thank you.
very quickly, 3 minutes left. So our correlations, you saw that before. This is the 247 features data set created automatically, all sorts of aggregates derived automatically by the engine. Here we have a subset of the features used by machine learning. So say like average balance, something about town. So this is a similar example to the PowerPoint. Marital status. So you can see there are some differences in the profiles. You can even see like the type of device they were using. I think we even had some regions. It's a UK data, so you can see the conversion rate, the way you read it in Stoke-on-Trent. I don't know what that means. Was much higher than in Islington. That's how you read it. Now, quickly, how do you use that in your future campaign? This is the screen I showed early on. You want to see, you have the scores, you have all your customer base scored, but where is the cutoff point? Like who to target, who not to target? The information is never in the scores. What you need to add is at least 3 pieces of financial information. So it's cost of action. In this case, say it's a cost of making a call. Say it's a 15 euro. Loss if failed, that came out through working with the client, where they said, well, they research, and when they target customers with wrong offer and they refuse, there's like a negative revenue effect in the future. So say it's 5, whatever. And then benefit if success. So say if we successfully convert it. So what these pieces of information do, they convert the scores into financial set of information. And what it's telling you right now, if you target everybody, you will lose here on the right, on average, 7 euro on every call. And overall, you will lose 94,000 euro if you target all the 13,000 customers. Now, how it works in detail, say if you target accidentally your bottom 5 percentiles of the customers, you will lose 13,000 customers. So that's a poor decision. But then as you move up with the propensity scores, all of a sudden, your campaign becomes profitable. And it's about finding exactly this cutoff point. In this case, it's somewhere around here, around the top 19, 20%, where the information is telling you, you will earn net benefit of around 55,000 euro by targeting 2,500 customers. But if you keep calling them, if you keep going down the scores level, then all of a sudden your overall revenue starts going down, because now you are wasting money on each marginal call and it's raised to the bottom. So that's it, kind of 5:30. And the last minute question.
Yeah, the target selection. So you made it look pretty easy by just clicking this and that. In real life, how does that work?
I'm glad for that question. So target creation, the selection bit is easy, but digging out the proper target and putting it to the form of a data set is probably the most difficult and challenging task in predictive analytics. This is the action that aims your gun, your machine learning gun, at the problem. And we see awful lot of projects delivered out there where not enough attention is paid to the target definition, as we call it, or objective, or labeling, as other people call it. This is extremely important stage. And this is still, there's no automation to it. This is where the science meets experience and meets business problem. And it's case by case. So do not expect junior data scientists to be able to do it, because no one is teaching that. There are no courses about that. There are no articles. It just requires a lot of experience and working with the business. And also, it's iterations. So I just make some hasty clicks here. We may decide, say, we don't want to include hangups in our negative profiles because we don't know who they are, or maybe no answer as well. Like, we don't know if they are positive or negative, so we may need to exclude and run another project as an iteration. So we go back on real life analytics and we make different choices, and sometimes we go back to the database and redefine the target. It's sorry, I could talk about this for a long time. It is crucial step in this process. Yeah.
Okay, cool. Well, look, we're 2 minutes over, so I'm sure people want to get back to their evenings or their mornings. Thanks for that. And we will send the recording of this out to the participants. If you have any questions afterwards, feel free to email us info@xpanse.ai, and you can always reply to the email in which you get the recording as well. So thank you very much, everyone.
Thanks, Sam. Thank you guys for coming. Take care.
See you. Bye.